Good afternoon, everybody. We're going to see a presentation from Job to Haas on side channel analysis on embedded systems. Job is from RiskCure, a company that does hardware security testing. He's an electrical engineer by training, and he has proudly said a long-time hacker. This is the fourth such event that he has been at here. And he will be answering the question of whether side channel analysis presents a threat for embedded systems. Is it as easy as people think? And at the end of his presentation, he'll be doing a demo, which you might want to stick around for. Please welcome Job.
Cool. It's a nice tripwire here across, so I won't dare move further. Welcome to my presentation. Like you see in the slide, it's side channel analysis on embedded systems. So I'm actually going to do presume already some knowledge here, which is always a bit tricky. How many people did see Jasper's talk yesterday on side channel analysis? Ah, that's good. Oh, great. Wonderful. At least, yeah, I can assume some knowledge. So that's good. Because actually I won't be talking very much on the details of how to do a correlation or a side channel analysis. I'm much more looking at an embedded system and trying to say, well, if you would want to attack it using these techniques, what are the problems you encounter and what are the techniques that you can use? So first, yeah, who the hell am I? Like the intro said, long-time hacker. I always think, ooh, I'm an old fart if I see this. My current role, before this I did pen testing, that stuff, but now I'm one of the directors of a company called RiskCure, and like you heard, we test a lot of hardware stuff, so we tend to take apart a lot of stuff, and in some cases side channel analysis applies. So side channel analysis is one of the core expertises of our company. So what I'm going to talk about is first setting a scope. Is, okay, what are we going to talk about as an embedded system? And then I'll try to guide you along the things that might make side channel analysis interesting for these devices and why, and also what makes it more difficult or more easy compared to kind of the benchmark, which is a smart card. And yeah, the last part is more of how do I assess a product, and when is it a risk for my product? Because that's in essence the question that everyone asks themselves. Okay, this technique exists out there, but yeah, is it really a problem for me? And when do I need to do something about it? First of all, kind of setting the scope. What kind of devices will we talk about? And I kind of separate two types. One I call microcontrollers, and the other type I call complex processors. Well, of course, it's a very vague term, and there's no clear distinction because it's a range going from one end to the others. But you kind of get the idea behind it. One is a very dedicated processor. It's often a simple 8-bit, 16-bit, and the other is a very complex system. It has multiple cores often, it runs at higher speeds, etc. And we try to separate these two because the application of side channel also divides a little bit along those lines. And if you think, what is he speaking very fast, that's because I've got a lot of slides. I'm trying to keep up the pace. If there's anything unclear, just raise your hand and I'll try to answer it. So what is a device? Well, of course, embedded device, it has a security function, that's pretty obvious. And the focus will be here on the passive side channels. So what does it mean? It means measuring and not doing the fault injection stuff that Jasper also talked about. But the big question is, of course, why? Well, of course, I already said there's a certain threat, but how big is the threat? And do I need to worry about it? How does it compare to smart cards? A lot of people in our field are very much used to smart cards. They've been testing smart cards for this, these kinds of attacks for 10 years now. So they're very used to this, and it's very difficult for them to compare what they know in that field to the embedded area. And of course, well, what's future developments and some demo stuff at the end. So what is new if you do side channel analysis on embedded systems? First of all, there are two kind of uses for side channel analysis. One is actually getting the keys out, and the other is understanding a system, maybe before you're getting the keys out, reverse engineering. So on embedded systems, you can use it to get keys and PIN codes and unlock codes and feature unlock codes and stuff like that. It all works, it's all been done. And for reverse engineering, you can use it to discover program flow. You can figure out maybe which crypto algorithm is being used, or you can even reverse an unknown proprietary algorithm using these techniques, depending on the leakage, of course. But if you compare this again against the field that's been used so far, actually not much changes. It's the same use, it's just a different device. So when do you start to think about side channel analysis? And this is where there's maybe a difference to smart cards, because with smart cards nowadays, it's a mandated test technique if you're doing a payment card, for instance. Every payment card in the world that's, for instance, under Visa or MasterCard has been tested on this. For embedded systems, of course, it's a completely different world. And that is also because there are some preconditions that apply. For instance, physical access. Is that applicable to your device, and in what sense? How much time, how much access do I have to carry out my attack? What kind of interfacing do I need? With a smart card, it's pretty obvious what the interfacing will be, but with an embedded device, there may be a wide range of varying interfaces that are available, or that you may need to be able to carry out your attack. And then, of course, the cost of equipment, and I already put some stuff on the table here, and you can imagine that cost can go up with a lot of physical testing, so that may also factor in the attack. And of course, again, it becomes interesting when there's a secret inside. You need to gain something. With embedded devices, often unlock codes and feature unlocks are also interesting, so it's not even about the secret key to do your payment, but it's just expanding the possibilities of your device. But also, it tends to only apply when other attacks are much more difficult, and that's kind of a theme that you'll see through this, is that the logical and the physical access protections already need to be pretty tough before you start to think about side channel analysis. So what does a typical setup look like? Well, basically what's in front of you here on the table is exactly this. It's only being replaced by some more portable devices. So we have a workstation, a laptop that does all the processing. It controls an acquisition device. In this case, it's an XY stage and an EM probe. So it's going to pick